Tonight, this is our first meetup, so everyone's kind of new to this group. We're really excited about it, though. Hope for a lot of really great stuff out of this. This is AtTask, obviously. I work for AtTask. This event is hosted by AtTask, so kind of a shameless plug. Come work for AtTask. It's a great place to work. If you want any information, please feel free to talk to me. I would love the referral bonus. So I'll give you a really quick background on AtTask. We don't come hosting this as if like we know everything about Angular. Actually, it's kind of more the other way around. That we've just recently adopted Angular at AtTask within the last month or two, and we're kind of looking around like, hey, are there any meetups that we can kind of get a lot of knowledge from and kind of glean some of the experience that other people already have, and didn't really find any Angular-specific meetups in Utah. Thought, okay, this is a great chance. Let's organize it and get some great people in and learn along with everybody else. So anyway, just again, welcome you guys all out. Thanks for coming. If you haven't had a chance, there's a little like trick or treat bucket back there. That's actually a raffle. Put your name on. We got a couple prizes at the end. That's about it. Oh, and this is being recorded, so this will be available on YouTube. We're going to create a YouTube channel for these. So if month to month you might not be able to make it one time, hopefully you can always just at least watch it and get some of the information. So our talk tonight's by Stobbe. And I'm over to him.
Okay. Hi, guys. So I want to talk about testing with AngularJS. We got Angular in our code base, what, like a month ago, maybe? Before that, we were on kind of a homebrewed legacy framework that turned out to be not sustainable in the long run. So we started looking at solutions, and Angular was really the place that we felt was going to be the best for our future. We don't have, I mean, somebody was saying earlier, we don't have, I guess I should put the mic on. We don't have all the experience. We're still learning, but we're doing this in production. We have features going out that are using Angular, and so hopefully we have some idea of what we're doing. From the beginning, testing and our testability story was a big deal for us. Historically, we've had a suite of Seleniums that take hours to run to cover our front end, and we wanted something that would run more quickly. So we turned to, as we turned to Angular, we found Karma, which is the test runner created by that team. And I want to start by just going into that and getting that set up. I'm going to try to live code this. Should be pretty quick. So if it's starting to drag it, I'll just throw something at me and we'll pick it up. So for Karma, it's just an npm module, npm install Karma, and then Karma init. There's a wizard that will take you through the different testing options. We use Jasmine here. That's what we'll be focusing on tonight. I haven't historically liked the BDD syntax. Thought it was too verbose. But Jasmine offers some really cool stuff as far as testing goes. It lends itself to self-documenting tests a little better than things like QUnit. What I was finding with our previous attempts at unit testing in JavaScript is that somebody would write an assertion and not label it, and so you would just get a list of failures. There were like line numbers and false in the code results. And so Jasmine kind of lends itself a little better to having some documentation there. We use require at work. I'm not going to use that for tonight, but Karma works really well with that. It can pull in your tests and any of your dependencies as require modules. There's documentation on the Karma site for that. And then it can capture any browser that you happen to have. We'll just use Chrome. But Phantom.js for your CI. It can do IEs. It can do Safari if you are even more in the Stone Age than IE. But all it takes is locations of your files. So all my files live in public.js. And that is not really readable, I apologize. And spec. So we have spec files and test files. And Karma is awesome, especially that it will watch your tests and files for changes. So that created this Karma conf. And that's just setting everything up. And this is all, it's all configurable. It's all JavaScript. So anything that needs to be configured in here. But then you just Karma start. And You can't see over here, but it's launched. Awesome. It's launched another browser. That's connected to my Karma server and is waiting for tests to run. So I've got some things blowing up here. My code is trying to use Angular and it can't. So I'm going to go through and the Karma server is, thank you, it's much better. The Karma server is really quite robust. You can give it, I mean, by default, you're just giving it a pattern. And you can see I'm using globbing here to pull in any JS or spec.js files. But under my public JS libs, I want to make sure that jQuery is loaded, then Angular, and then everything else. So I can pull in my libs, and so the way that this works is it pulls them all in, it'll serve them, and then it gives you. All right, well, that didn't work because of errors.
Relaunch your browser.
Yeah, I relaunched it. So and so that's just an object of anything that it's serving in the last timestamp that it updated. So it's really cool. You can load fixture data with it. You can load pretty much anything you want with it. And as long as it's been loaded into the server, you can reference it later. So with this pattern, it's loading them in and it's watching them. So if these files change, the test will rerun. And it's also serving them. Like if you're using require, you can tell it don't serve the files, just include them with the web server so that require can request it later. But for now, it's just watching all of this list of files that we've said and is waiting for changes. So let's go into our example spec. So I just have an empty file. Is anybody familiar with Jasmine, or do you use it at work or anything? Yeah? So it's just Jasmine, and then Angular gives us some wins on top of that. So we will, oh, sorry, hold on. My code's going everywhere. So it's just a series of functions. Jasmine describes expectation sets, I guess, called its, and then the expect methods themselves. So we're just describing an AngularJS test suite, and we can give it, we tell it our expectations. And in this case, we'll expect true to be true. And you can see, as I updated that, my test reran, and now they're all passing, which I hope they're passing, otherwise we've got some serious problems. But this will happen in any browser that you have connected. I mean, it can handle any arbitrary number. The browsers don't have to be running on the same server as the Karma server, so it'd be easy to run IEs in a VM and just connect to your Karma server and run the test there. And then this debug panel is the test bed, and in there you can get access to anything that's being required. So we're pulling in Angular, and we're pulling in jQuery, and those are all available. So if you do need to play around and play with your values outside of the test environment or outside of your test suite, then the debug panel will give you that. So that's just basic Jasmine syntax. And then we get into the cool stuff. So the Angular injector just takes a function, looks at it, and says, what do I need to inject from this? And the ngModule library that we are pulling in our, actually we are not pulling it in. The ngModule library gives us access to the injector function and a module function that we can use. So with our expectation set, we can tell it, we can say, we're injecting dependencies, and then use inject with our function. And Angular now knows how to inject dependencies into your tests. So I'm going to inject ng resource and expect it to be defined. And we're going to get an error there. Oh, crap. Inject isn't defined. So we're pulling an Angular mock, and we don't have that. So give me just a second. I apologize. Oh, yeah. Good call. So Karma won't watch its own comp file, which is, I don't know why that is. If you try to tell it to watch it, it just says, I'm going to ignore my comp file. So you get that. So we're getting an unknown provider because resource, as of Angular 1.2, has been moved to ng resource. So I can come up here and say, before each test, so this is another Jasmine construct, and then we have a module function that ngMock gives us, and we just pass it the name of the module. And it ensures that it's loaded before all the tests run, and you can see now resource is defined. And then if we, this is most useful for loading modules that you've defined in your code and that you need to test. But if you have to, you can create your own modules on the fly. I can say, is it provider value?
It's actually provider.
Well, so they're all.
Your passing parameters provider.
Is it? No, let's find out.
In your before you
The parameters.
yeah on.
All right, thanks.
There you go.
Typo. Part of the problems of live coding, access. So again, what do we call it? Eval. Huh. Well, that usually works. Oh, I had it outside of not actually putting it in the right place. So if you use it right, it will inject it correctly. So like I said, mostly you'll be loading modules that you've written that are under test. But if you have to, you can create your own. That's useful for mocking values. Like if I had my foo value was pulling from the database and I just wanted to mock it quickly, I could create another module to override it because Angular doesn't handle namespace collisions very well. So if I overrode a foo value from another module, it would just serve that, which is great for if you want to override like cookies to give you a specific value instead of looking at your actual cookies or whatever. So that is the part of that is cool. The other thing that it can do is compile Angular expressions. So we're going to inject again, and we are going to inject a function with root scope and the compile. And this is all happening behind the scenes anyway when you are using Angular, but we're going to be a little more explicit about it right now. So we're going to assign a value to our root scope. Normally you wouldn't be doing this, but while we're testing this example, it's probably fine. And then we'll create an Angular expression, and we'll just say some. Awesome. Can't work my fingers. And then all that we have to do then is pass our expression to the compile function and tell it the scope to evaluate. And at this point, we can expect our element. We can expect our element.html, which because it compiles it into an instance of an Angular element, not to contain what we expect it to, because then we have to digest. And so, I mean, a lot of the stuff that Angular is handling manually or automatically for you, you have to do manually in tests. But it does give you a lot more finer grained control to check each step of the process. And then, so you can see that's passing. It doesn't contain that yet. And then after we digest, You can see all our tests are now passing. That becomes a lot more useful with directives. You can compile your directive and make sure that it's outputting the HTML that you expect, or any other more complicated Angular expressions that you're doing. So that is our, actually one last thing, is we can provide controllers. And that's going to be a big part of being under test, is the separation of concerns there. So it's a little more convoluted. We're going to create a scope. And we're going to create or get a controller. And we have a controller in the code that we're going to be testing. So we'll just pull it in now. Actually, let's go back up here. So in our provide function, let's inject and so we will create a new controller for our test environment. And like I said, normally you would be pulling these in from code under test. So controllers can have a scope, and they can also attach functions to themselves. So we'll just do a reverse function. So now down here we can inject our main controller. And pass it our scope, our new scope. We could pass it the root scope if we wanted, but let's not pollute it like that. So we'll pass our scope. And these are literals that will be made available on the controller, but generally we're just passing scope. So we'll expect our scope.hello to be world, because that's what we assign it to up there. And as it's getting bound to the controller, it's applying all of the scope actions that the controller is doing. And then we'll expect control.reverse of some string to be the reverse of the string. So what we did there was we injected our own controller. We just added stuff to the scope and then tested that when we bound the controller to the scope, it was all behaving as expected. And again, that becomes a lot more powerful when you have production code under test. So let's get into that. I created a really basic API for our to-do app using Node, and then created the Angular app. So we can create new stuff, save it, update it. This is all going back to the server. And part of the reason that I did this is that Angular has really cool tools for mocking HTTP backends. So like if you use resource and stuff and you don't want it to be hitting your server during your unit tests, there's a lot of cool mocking tools that can assure that you are making the right assertions, and making sure that you're making the right number. So let's go into that. We're going to create another describe down here. And we'll call it our test app. Let me just give you some, put it in the middle. And so the first thing that we'll do is mock our HTTP backend. So before each, we're going to want to pull in our to-do app module. And then we're also going to want to have an injected function before each of our tests that is pulling in our HTTP backend. Angular ignores leading and trailing underscores when it's injecting. And the benefit of that is that I can have a variable named the same thing as something that I'm trying to inject and not have to go through hoops. So I just injected our HTTP backend, which ngMock is overriding with our testable backend, our trainable backend. And I'm making that available to each of our tests. And then after each test, it has two convenience methods. called verify no outstanding expectation. I hope I spelled that right. And verify no outstanding request. So when you're training the HTTP backend, you can train it for two kinds of things. You can make an expectation saying, if I'm not called with this URL and these headers and this data, then the test has failed and you should throw. You can also just train it with data to say, if you call me with this URL, return this data. So it really depends on what you're testing. If you're making sure that your services are calling when they're supposed to, then expectations are the way to go. If you just need to provide data to them when they do happen to call, and you don't care how many times they do that or whether they do that at all, then setting up requests is what you want to do. So we can, if we go to our code, my to-do factory, all it is returning a resource to my API and binding the ID. So, I mean, I could get and pull resources. The resource, it has all the standard methods: save, query, get, delete. I could mock this if I wanted. I could override that. If I was testing some part that relied on that and I didn't want to worry about the backend, I could just mock the to-do method with whatever data I wanted. But in this case, I want to train the backend so that when the to-do calls, I can get the data that I expect. So it should return a list of to-dos from the server. And I am going to inject my to-do. Let me widen this a little. And then I am going to set up some expectations, right? And my API, the to-dos in my API are at /API/to-dos. So that's all I'll expect. And if I wanted to, I could set up expectations for headers. Like if I wanted to expect that I was sending an authentication header or a certain content type, I could set those expectations as well. If I wanted to expect that I was receiving some data, like in a post, I could set that. But for now, all I care is that it's being called. And when it does, I want to respond with a 200 and an array of to-dos. So I've now trained it. And so I can say my to-dos is to-do.query. And again, at this point, it returns a promise, but the promise doesn't resolve until I tell it to. So at this point, I can expect to-dos.length to be 0. And let's find our tests. Oh, yep. So because I have an unflushed request, and I'm verifying that there's no outstanding requests, right now my test suite is failing. If I had removed that assertion to say, I don't care if there's unflushed requests at the end, then we would be passing now. So we've got a promise back of length 0, and then we explicitly flush the backend. And again, that might seem kind of annoying. It's adding a little extra boilerplate, but it's giving you precision control of any step of the lifecycle of your request. So after we flush, we can expect our to-dos.length to be 2, because that's what I've trained it to be, or trained it to send back. So again, it's all promises behind the scenes. It's just, I guess, at your beck and call. And then the next thing I want to do is test my controller. And so if we go back over to our app, you can see our main control is querying to-dos. And I kind of broke this out funny because I wanted to demonstrate compiling directives. And so I have a directive that's laying out my list of to-dos, but I have all of the logic related to going and getting and deleting and updating to-dos in my controller. So we want to inject a root scope so that we can create a new scope for our controller. And then the controller. This is the same that we did earlier, except I have to inject a function. If you do it right, it will work. That is too many nested things. Is that right? Looks like it. OK, so in this case, we're just going to borrow our backend training again, because the controller is making that query. And then I want to
like that expect get you're doing, like you could put that in the before each if you wanted to train it like
yeah,
every single time.
exactly. The reason I'm not is because I'm running some tests that I guess I'm actually not. Yeah, so I could put it in. If I was expecting it in every single test, I could put it there. Again, it's also, I can also do like expect post and expect delete and things like that if I want to train for those. I'll create a scope, and this is something that you could do in a before as well. And that would probably actually be a really good candidate, is just to reset your scope to a new child scope. And then I'll inject our main control. And give it our scope. So at this point, it's created, it's bounded to the scope, and it's done all its actions. So it's gone through, and it will have run our to-do.query, but the backend isn't flushed. So it's adding it to the scope, so we can expect that length to be 0, and then flush our backend. And so we're passing up to that point. It's a little green there. And then our scope.todos.length will be 2. So we've now tested that our controller is going out and getting data as we expect it without ever actually hitting our API. We could test. We won't go into it because it's just variations of what we've done so far. But we could test. We could set up expectations like for a delete, and then go and tell it to delete one of the apps. Run it through that, and make sure that the delete is being called. We could tell it to expect new to-dos to be coming in. The last thing I want to do is compile a directive for a more in-depth view of what we did earlier. So we're going to inject that, and we are going to require our call it to-do list. So we want our compiler as well. So we'll pull in again, and so yeah, let's go ahead and refactor to that. So before each, we'll create a scope. We'll pull in our root scope, if I can find out where I am. And then we will say scope equals root scope. Right, so now in each of these locations where we previously were creating a new scope, we no longer have to do that, because the beauty of Jasmine's before eaches is they're run not just before each assertion set, but before each test. So they're all being reset, and we can expect clean data in our tests. Well, maybe not. Let me go to my reference code really quick. I really apologize about that. I don't have that. So any questions so far?
Is it possible to inject multiple things in the before each, or can you only do one injection?
It's possible to inject any amount. So yeah, I mean, I could have done it here. That's a good point. It works just like the Angular injector does.
Okay.
And that'll be functionally the same. We're still passing all our tests. Great question. Any others? OK. Give me just a second to catch up with myself. Okay.
Could you be setting an instance variable or a variable at the top of the page instead of just setting it locally there?
Should I be?
Scope is equal.
I could, yeah.
The scope is
It's just JavaScript.
valid there. Maybe that's what it's failing.
Is it failing? Are they?
I don't think it's bad.
To-do list.
Oh,
Yeah.
Okay. I had one more piece that seems to be missing from my notes. So again, that's all just a few things that Angular has provided. It's provided the inject function. It's provided the module function that's loading our modules. Everything else is wins from Jasmine. Jasmine has an extensive mocking library. So if I did want to go in, like we talked about, and mock my to-do, it's not in that code, it's in this code. If I wanted to go in and mock my to-do, I could mock it with a Jasmine spy, and that lets you watch method calls. It lets you override method calls so that they're being captured and not passed through. Or you can just make sure that they're being called and pass them through to the original resource there. So Jasmine provides a lot of really cool mocking like that. One thing I wanted to do was show some examples of how we're using this in production. And I got my bosses okay from this, so feel privileged for company secrets, I guess. Like I said, we have had Angular in the app for about a month now, and we are going through and systematically attempting to expand our code coverage. So like I said, our previous code coverage was all Selenium based, and so we're going through slowly. I want to show you something a little embarrassing, and that would be our coverage. So this is something that is just it's a win from Karma itself. So we're using a coverage preprocessor, and here you can see we're using require and setting that up in our test main. If you use require, it works really great with Angular, and Karma has gone through pains to make sure that it works equally as well. It has a built-in require framework or loader that knows how to handle that. So all we're doing is adding all of our tests to the methods to be required. We're doing a little setup for non-AMD modules, and then passing the dependencies and saying window Karma start. That's really all you have to do to use require with Karma. There's documentation to that effect on the website, but it was super simple. And then your tests as well as your features are require modules, which is cool. So with our coverage reporter, we have two different reporters set up. One so that we can see the progress of our tests, and one so that our instrumented code is run through Istanbul. And that gives us, oh look, Chrome is updated. That gives us stuff like this. So like I said, a little embarrassing. I've been working on this for a week or so now. But it built in with Karma. It'll give you Istanbul coverage. And it's line by line. It's pretty sweet. It's not perfect, but it's a really cool metric to see where you are with coverage. And as the cool thing about, because Karma reruns your tests automatically, your coverage is updated live. If you wanted to, you could watch for changes in this directory and have this refresh so that you could have a standing output of what your coverage looks like. But this is all updated live because it's instrumented and run through it with every test run. That's one win that we get from Karma that I don't know if you've tried to set up Istanbul before. I've tried and I couldn't figure it out. Maybe I'm just below average intelligence here, but Karma made it really easy. It was 2 lines. You add it to a preprocessor and add it to your reporter. The other thing that we have looked into, so our Seleniums are run from Java right now, but the Angular team or elements of the Angular team have put together Protractor, which is a way to drive an AngularWare Selenium binding from Jasmine. And this is just some sample tests that came with it, but looking at it, I mean, you can see we're finding it by bindings. Like we're finding an element by its Angular binding. Or down here, it understands repeaters. And so if you're using Seleniums for end-to-end or scenario testing, then Protractor is really an awesome way to go. It's still slow. I mean, you want to do as much stuff on a lower level as possible. It's still slow, but for scenario testing, you really can't beat it. So we can come and run. There's somewhere. So it fires up a Selenium server. In this case, it's just using the one that we're using. And it will launch a browser. I'm hoping that it launches in that side. Nope, here. Launches a browser. All it's going to do is AngularJS. It's finding the binding, and that happened really quick. But it's finding the binding your name, and then so it's inputting stuff, finding the binding, and expecting it to equal the given value. So AngularWare Seleniums, probably about 1,000 times more awesome than normal Seleniums. And then the last thing is test data. One of the things that we tried, or one of the things that I tried to do is write as few Seleniums as possible. If those completed at all, like yeah, see, it hung up trying to run that, but it did it in 10 seconds. It probably ran the 2 tests that passed in 2 or 3 seconds, and it just doesn't scale very well. So one of the things I was trying to do is to run our test coverage, our test suite, at as low a level as possible, as close to units. That's not always possible. Sometimes you do need to DOM manipulation. So there's cool stuff that comes with that.
Did you try Angular Scenario Runner?
I didn't use Angular Scenario. I'm not very familiar with it, but
It's very similar syntax and it works pretty well.
does it? Okay. What I'd read was that Protractor was recommended over Angular Scenario for new projects, but we can check into that if you can make a recommendation in that direction, then we'll look into that.
Compare it. Can you tell me a little more about Protractor? Who makes it?
Let's pull it up. It is the.
I think it's a new person that Google hired that they did it for a summer of code.
Yeah, so it's an official Angular project. It's under the Angular namespace, and then this Julie MR person is the head on it. So ng Scenario now refers you to Protractor for end-to-end testing, which is why we decided to look at that over ng Scenario. So this is official. I mean, it's only going to get better. Right now, it's a little buggy, but it's being actively developed. Sounds like it's her job now. So.
It's built on top of WebDriver.
Yeah, it's built on top of WebDriver, and then I'm using Chrome driver to run the tests in a Chrome harness. We want. So yeah, it takes very little setup. You just point it to your Selenium server jar, and then tell it what ports to run on and where to find its Chrome driver if you're using that. If you're using Firefox or other things that Selenium has native support for, then you don't need to do that. But then it's really similar to Karma's setup. You just give it a location for your test specifications, and it goes through, and it's happy to run them all day. We are using get JSON Fixtures. So this is Jasmine jQuery, and it just happens to work really well with our goals of keeping stuff as low as possible. So we are loading this fixture data, and that is JSON data and then HTML templates, and using those. So one of the nice things is that it loads it and resets it before every test. So you're adding stuff to the DOM. Because it's running in a browser, you can do this. It's adding stuff to the DOM, but then is resetting it so you don't have a polluted DOM before the start of your tests. So these tests here are actually rendering SVG elements with D3 inside the browser during testing. and we can look at that. So it's going to fire up. For our CI, we use Phantom, just because we don't have to launch a browser. All our tests run. So including DOM manipulations and rendering stuff in SVG and using the DOM, which is normally stuff that's higher level than units, but that I didn't want to put in our end-to-end or our Selenium testing. So including all of that, it runs our 51 tests for this in 3.7 seconds, which is huge, huge wins, probably an order of magnitude faster than Selenium, while still staying as close to the middle as we can get. So those are the wins that we found, is that the way that ngMock works with Jasmine is really conducive to writing tests quickly and to being able to expressively declare what you're doing. Like I said, what we were seeing before with QUnit or NodeUnit is that we would have a lot of undocumented assertions. Like I can see what you're doing in the assertion, but there's no documentation as why. So here it's as close as you can get with having good documentation and then injecting inline Angular components so that you don't have to have a different solution. I think that's it for me. Any questions?
How extensible is it in terms of doing stuff just completely outside of browsers? And then also I was gonna ask if you had somebody that was doing like WebSockets and you wanted to do sort of extensive testing of the data that's coming back and forth with sockets, and you have like, sort of a callback chain associated with that. Would you suggest using this for that or something similar?
I don't know if I can recommend Jasmine for that. One of Jasmine's goals is to run your tests where the code runs. So because it all runs in the browser, it wants to run your tests in the browser. So if you want lower level testing than that, there are probably other tools that are better, NodeUnit or whatever. But Karma has a bunch of different frameworks. So built in, I think it comes with Jasmine and Mocha and QUnit. But it's really simple to write your own framework to do whatever runner you're looking for. And in that case, it becomes as extensible as you want. So JS test driver, I think, is what spawned Karma. It's kind of some of the problems with JS test driver were what led to Karma's creation. But it even has a framework created that will run JS test driver's tests in Karma. So it's as extensible as you want it to be. You can do some crazier stuff. You can get down in there into the middle. Karma uses a dependency injection that's inspired by Angular's dependency injection. So you can ask and change any component. So if you're willing to get in there and get messy, it can be as extensible as you want for your testing purposes. Thank you. Any other questions?
What's your backend written in?
Backend is Java.
So how do you do integration tests? Do you do like live data serving by your Java server, app server?
We do at some level. So all of our end-to-end testing spins up a live instance of AtTask, populates it with test data, and serves it from there. I'm sure we have some middle layer tests. They're nodding back there, so I got it right. That's not really my expertise, but yeah, we do passing of data and stuff like that. And so one of the cool things about Karma is because it's just running a test server on a different port, if you wanted to or if you needed to, you could fire up an instance of your application and have it serving data to your Karma tests. Thanks. Anybody else? All right, guys, thanks for coming.